Okay, let us go back to assignment 4 a little bit. At the end of assignment 4, we kind of add a overloaded operator, right? We use the minus sign stand for a cut, unary operator cut. And I might like to add another one. Suppose we add another symbol. I do have a list in the explanation right there, right? So these are the default symbol or binary operator in C# programming, right? So actually, you can implement any, you can override any operator on it. Suppose right now, well, I think this is tilde, right? If I use the tilde, this operator for concentration, okay, I can define it because it is a unary operator, so no problem for that. So I kind of cut and paste, but pay attention to that. It is easily, incur some exception. All right, so I redefine tilde. And since tilde is a standard unary operator, we don't need to have any parameter value. So I don't need this parameter value at all. So I kind of define this tilde as a concentration operator, right? And since it's a unary operator, so only work on 5Z. So we always treat, no matter it is triangular or bell, does not matter. Every children of the genetic 5Z class can be regarded, can be treated as the super labels references. So we kind of deal with that. And then once we generate, the generated 5Z is a unary operator 5Z, right? So it's okay. We kind of specialize that as a unary operator. Last time we also specialize that. But again, you can think about that. A genetic 5Z after the concentration operator. Even those, we know the result should be unary operator 5Z. But we don't need to return that, right? But that's okay because in particular it is a unary operator 5Z. But as I said, the object of the derived class can be regarded as the superclass references. So actually, if you like, I can return a genetic 5Z. There's no any problem for that, all right? Okay, so since this one is for concentration, right? So I need to prepare a new concentration. Okay, we have concentration 5Z operator. This the operator does not need any parameters, so I can create an operator. You see, in fact, we instantiate an particular operator, right? It is concentration 5Z operator. But again, this object can be stored in a superclass unary 5Z operator. So we treated that as a general 5Z operator, right? So we actually create unary operator 5Z, right? But the result, so result is okay. Result still is a unary operator 5Z. Does not matter, but it can be returned as genetic 5Z. It will be much, convenient for the user to do it. So there is no any conflict because result is actually an object of unary operator 5Z, but it can be regarded as regarded as a genetic 5Z. So this one is a newly added overloaded operator tilde. So tilde meaning it's a concentration operator. So if I have this notation, then I can go back to the unary operator 5Z button here. Create a unary operator button, right? So similarly, remember that the derived class object can be regarded as the superclass reference. So here again, similar work can be reduced, right? The one I just tell you before that. Now add the 5Z button. We don't need to duplicate a lot of code there. Every instance of derived class actually we assign into the superclass reference right here. So Gaussian fuzzy set is a generic fuzzy set, right? Triangular is also a generic fuzzy set. So we kind of store our reference in this generic class references, and then we apply similar assignment code right here. So similarly, let's go back to our unity operator fuzzy set right here. As you can see, in each case, you need to create particular fuzzy set operator, right? But we don't need to prepare a particular class variable here. So what we really need is a generic class reference. So that should be unary fuzzy set operator, OP. Set it to the initial value as none, right? So 0 is for negate, right? So here, I actually instantiate a negate fuzzy set operator, but I store the reference into the superclass reference right here, OP. Okay, and then we create a unity operator fuzzy set, right? So we send OP to it, so we get a fuzzy set. Again, that is a unity operator fuzzy set, right? Okay, so similarly, we can move this local variable up to here. So initial is none. So then I repeatedly use this variable name here. But as you can see, in fact, we don't need to specify that as a unity operator fuzzy set. We can directly call that generic fuzzy set. It is still okay. So actually, what we instantiate is a unity operator fuzzy set, but a unity operator fuzzy set is again still a generic fuzzy set. So we can keep that code here. All right. So after I assign the OP, I create an OP and generate negate. Well, maybe I should change the name. I change the name, rename it as unity operator fuzzy set, UFS, to let you see what happened. Okay, so UFS set. Then I move this part of code back outside the switch statement, right here. Okay, so your implementation will be much more simplified, right? Great. Concentration right here, concentration operator. Okay, again, OP will be all right. OP UFS. So the beauty right here, remember that, even though you instantiate a derived class object, it can be always stored in the reference of the superclass. That is the method we have been using right here. So we don't need this code. We still need a break statement here. Okay, again, OP UFS, right? So similar coding style, you can repeat. You can copy that for your binary operator. OP UFS. So I needed to make them complete. So just give me a minute to let me finish that. Okay, so right now we have parameter, right? Cut. So in particular, it's a cut value, cut fs. Oh, okay. Last time we kind of use this skill, right? So right now, since we have minus operator overloaded, right? So we pick up the initial parameter value and use that to cut fuzzy set. Okay, so that is our UFS. So we don't need to instantiate OP anymore, right? We just directly pick that up. So this is the cut operated fuzzy set, right? So we kind of use this notation, use this value to cut the selected fuzzy set, return the UFS. They are always OUS, so we don't need to instantiate OP because within this overloaded operator, actually OP will be instantiated there, right? So we don't need to specify that anymore. So again, OP is here. OP, right? UFS. Tree node, again, we don't need to do that because these calls are exactly the same. Case 6, OP, UFS, OP, seventh one will diminisher, right? Diminisher OP UFS. All right, it's about the end. We modify our call into this style. So OP has been instantiated with a particular fuzzy operator. And the UFS, well, we know definitely that should be a unity operated fuzzy set. But again, we treated that as a generic fuzzy set. Generic fuzzy set. It is okay. All right, so we kind of assign that, and back. So we have our unity operator ready for us to use. So the coding should be much more simplified, right? So input universe, we can create a universe. Within this universe, we create Gaussian fuzzy set. So if I create on this Gaussian fuzzy set, I can select maybe negate, right? Concentration, all right? Not dilation, cut value, right? So we need to specify cut value. And we also have a value scale, maybe 0.8, create 1. Okay, so normality does not hold right anymore, right? So intensification, never mind, just take that. Okay, so once user change the parameter, for example, right here, change the mean into 0, every derived or any dependent fuzzy set will be also changed too. Okay, that's good, right? All right, so maybe why we need to use the operator uploaded. Take a look at this expression, right? So usually you need to create a particular operator and then use that to instantiate a unity operator fuzzy set, right? But here it's very clear, right? We directly pick up the cut value and then use this notation, use this operator to generate a fuzzy set. So it's an arithmetic operation on fuzzy set right now here because we kind of override our operator. So let's go back to our operator. We try to add another unity operator. Choose a symbol for the operator overloading, right? Okay, so let's go back to generic fuzzy set. So again, this one we just made, right? And we just finished this so-called, well, that is a concentration. So we try to replace our code with this notation, delta. So we kind of use delta as a concentration symbol. So we return to our code here. Take a look at this case. The cases should be concentration right here, concentration. So normally you invoke the constructor, right? So target is where? Target is this guy, fuzzy set, right? So this is the target fuzzy set. So right now, I apply an operator, delta operator on it. So the result will be what? Result will be a unity operator fuzzy set, UFS. You see, isn't it beautiful? right? We don't need to use this kind of notation anymore, which is similar to this statement, right? Muf equal, well, give it a cut value, and you just cut minus the fuzzy set. So the result will be a fuzzy set. In particular, that is a unity operated fuzzy set, right? But again, we treated that as a generic fuzzy set. There's no any problem for that. All right, so that is the beauty of using this kind of notation. Actually, the mechanism behind this symbol is the we call operator overloaded, right? Because you can see minus sign, minus this operator have been using in a lot of places, right? Numerical number subtract the other numerical number, right? So we kind of call this kind of situation overloaded. Yeah, okay. All right, so since we have these two, right? So I think this guy has partially finished some binary operator. So again, similarly, we can add a binary operator. We will make an operator overloaded. So we return to our generic fuzzy set. So it's a unary operator, right? So suppose right now I like to make this notation AND for intersection. Binary operation on fuzzy set, right? I like to I choose this operator to overload the ampersand operator for our fuzzy set intersection, right? So you need to do what? Public, right? Static. What kind of fuzzy set will be returned? In particular, should be the binary operator fuzzy set. But again, I don't need to specify that. I can specify that as a generic fuzzy set. Well, it's up to you. But right now, similar to this unit operation, to make it you clear, so I might say that, well, I will return a binary operator fuzzy set. That is a particular type of fuzzy set. But intrinsically, they are the same. All right, so it said you will return a binary operator fuzzy set. And what kind of notation you will be using? What kind? Which operator you want to overload it? OPER, So that should be the keyword. You cannot change it. So I kind of use n%. This notation. This notation actually is used in C# programming is an AND, bitwise AND operator. So since it's a binary, this guy is binary, so you need to take two parameters. So these two parameters are generic fuzzy set, OPERND1, operand 1. Generic fuzzy set, OPERND2, to operate. Okay, so I try to override this guy, and I promise I will return a binary operator fuzzy set. Fine, I will return a binary operate EIN binary operator fuzzy set BFS new, right? So what kind of operator should I? You need to provide a binary operator. Get it give both operand, right? So what's left should be an operator. You see, we treat no matter it is what kind it is intersection or union, they are always regarded as the superclass binary fuzzy set operator. Fine. So here we have binary fuzzy set operator. I might call it OP new. We need to new particular binary operator, right? So that should be I don't know. That should be intersection intersection fuzzy set operator. Oh, okay. We have intersection fuzzy set operator. That's it. So I have OP ready, right? So I have OP ready, and then I can ask this OP. There's no any parameter for intersection operator, so it's okay. OP. How about operand 1, operand 2? Right? That's it. So we have this one generated, and then we just return BFS. So we kind of group these two statements within this overloaded operator. So right now we have ampersand can be used. Ampersand stand for what? Stand for A union, excuse me, A intersect with B. All right, so let us go back to our create binary operator file set right here, right? So let me check about the code right here. So user has specified two file set correctly. We need to make sure correctly, and then we will generate a binary file set, right? You see the similar structure right here. So what we need is that, well, this time we are not going to instantiate the operator by ourselves, right? We know the first one is the intersection operator, right? So what we really need is that what we need is just a binary operator file set, BFS, right? So in case of zero intersection, right? So that should be the BFS equal what? You got two operands, right? So it's pretty simple. File set 1 and file set 2. That's it. So you got a BFS, right? So BFS ready, right? So that should be the Trino BFS name. Tag equal BFS. BFS. Set tree no. Excuse me. Yeah. Set tree no. This TN. Yeah. Set tree no TN. Okay. I think we have something wrong, right? Tag B. Tag no. Excuse me. Dot tag. Tree node intersect tree node. Tree node. It's weird, right? Just instantiate it. Tree node tag set it. Set trigger. Yeah, that will be correct statement here. And then tree node parent add this tree node. Okay, we need to show the generated binary operator file set. So we add it here, and then also show the curve here in the chart. So actually, I can move this code to outside. Right. So what we left just a union. Will that be difficulty? Not at all. So let's quickly go back to here. We add another binary operator overloaded. So this time, I'm sorry, purposely I said, well, it will return generic file set. So did you see? Well, actually, this operator overloaded. I should use well generic file set, return generic file set back to you. You don't need to know in particular what kind of derived class has been created. We don't need that. So suppose I use or vertical operator as the or operation, right? So what we need is that, well, I cannot new intersection, I need union file set operator, right? So OP. So the rest of them should be exactly the same. Even those the local variable is a binary operator file set, right? But it can be regarded as a generic file set returned, right? So it's okay. So no matter whether you specify this type is a binary operator or you can directly specify as a generic file set, it's okay, the same. They are the same anyway. All right, so we have this kind of notation ready for us to use. So let's go back to our code again. See right here, intersection. 1 intersects with B with that symbol, right? So we kind of hide all this detail within this overloaded operator, right? So here, BFS equal what? File set 1 or file set 2. That's it. So we can delete it. But the problem generated, right? Why? Take a look at your overloaded operator. The returned file set, we know intrinsically is a binary operator file set, but we treated that as a generic Fuzzy set. So you got a problem right here because your BFS is a binary operator Fuzzy set. Never mind, we just change it out as a generic Fuzzy set. BFS generic Fuzzy set. Everybody is happy. Okay, even though this n% return a binary operator Fuzzy set, but again, that can be regarded as the generic Fuzzy set. So it's okay. It will be perfect right here. All right, so BFS right now we need to give it an initial value. Otherwise, the compiler will complain. All right, so that's it. Your coding will be greatly simplified, right? So yes, it's very clear for that. All right, so maybe we like to check the code execution a little bit, right? So that's okay. Static, I don't know what. So create a Fuzzy set, right? On this Fuzzy set, what we essentially is universe. Universe add a Gaussian Fuzzy set again. Add a property triangular. So right now we try to generate a union. So you need to do some logical checking. So right now, suppose user click on this guy. Let me show you. If I define here, I define another universe, right? Within this universe, I define another Fuzzy set. So we try to generate a binary operator Fuzzy set. So we select Gaussian one, click on this guy, right? And if a user select another Fuzzy set defined on different universe, click on here. Well, the best way is that you are not going to allow this setting happen. Otherwise, you should do some guard checking. This button will not be enabled because both of them are not defined on the same universe, right? So you need to do such kind of logic checking. So right now, Gaussian one is right here, right? Oh, well, since I click again, right? So click around because this is highlight. So right now, better and better. So it's legal, right? You see, this button is come out. So if I again select Gaussian one, click on this guy, this button is disabled right now because we kind of have prepared a function, a logical checking to check the universe whether these both the universe are the same. Only when both universes are the same, then this button is available. So you need to do this kind of for-pull mechanism logic in your probably in your definitely when a user click, right, when a user click on this label, the event happened, right? So during that event, you kind of need to check the other guy whether both of them have Fuzzy set defined it, and then both Fuzzy set had the same universe. Only in this case you enable this button. Otherwise you disable it. Okay. So now we have triangular and Gaussian special. So we are about to create, for example, intersection. Click on intersection. So we came to this place, right? All right. So let me set a breakpoint. Generic Fuzzy set. So set a breakpoint right here. Set another breakpoint there. Okay. Then we kind of hit F10 key. So we came to this place, right? Intersection uses this ampersand operator. So again, we create intersection operator, and then we create a binary operator for this set. Use this operator one. See, it's a triangular. This guy is a Gaussian. So after the creation, we actually instantiate an binary operator for this set. But well, okay, it will send it as a binary operator for this set. It's okay. So right now, BFS is in fact, up to this point, has not been assigned to the left-hand side yet. So once executed, BFS is a binary operator for this set. So after this point, then we came to this statement: create a tree node, set tree node, add that to the tree view, show curve. So populate the series point and then add it to the chart. All right. So we have a intersection, right? So similarly, if I select union, both of them can be generated. So I create again. So this time we enter this this function. If I hit F11 key, come to here, create Okay, step by step we get if I union operator union. After that, create a binary operator fuzzy set. BF is ready. Return it. Return it. Similarly, we carry out these trinomial instantiation style. So now we have this. We have 4, right? We have Gaussian, triangular. We have triangular intersect Gaussian, right? These two are dependent on these two, right? So if anyone change its parameter, we should accordingly change, right? So suppose I change the Gaussian center from 4 into -4, enter. You see, the union change to, intersection change to, because we have a perfect event triggers mechanism, so they can trigger that event automatically through a chain reaction like that. So the beauty is not just here. Okay, suppose I add. You see, so right now we have what? We have this kind of operator can be freely used. Intersection, union, concentration, cut, right? So we have this kind of operator that can be used. So later on, probably during some kind of operation, you might have this kind of situation happen. Suppose I have button right here. So I button one here. So I kind of pick up a universe from user selection. I user select norm. It must be universe. So it's a universe. And then since I use S, right? If U equal none, then I will return. Because probably users the selected node, the tag is not universe. It probably is none, and it probably is fuzzy set, right? So I need to make sure user click on universe, because the fuzzy set I generate, I need to place it on the selected universe. So I kind of create a triangular fuzzy set right here. Maybe do I have a trapezoid? Yeah, I have a trapezoid fuzzy set. So I have defined a fuzzy set, generic fuzzy. The object I instantiate is a trapezoidal fuzzy set, but I treated that as a generic fuzzy set A. Okay, so I have a B. So pay attention to here. So if I use what? Maybe I have another B ready for me. So I kind of new bell, new left right fuzzy set. Again, I need a special U for that. So both fuzzy has been defined on the current U. And I'm not going to show A and B for you. I'm not going to show these two guys for you. Okay, so I'm not going to set tree now, add a chart to the chart. No, I'm not going to do that. But instead, I kind of use what? A intersect with B, right? And union with 0.5 cut B. After that, I kind of use concentration. See, we can express our expression in this way. Just use the operator we have been overwritten, that we have overloaded, right? So these are the operator we just created, and then we can generate a fuzzy set. This kind of generic fuzzy set C equal Is it working? Let us see. So I have C, right? So I have tree node created. Tree node C. I use the C name and the C set tree node. So I like to edit the resulting fuzzy set into our chart. So fuzzy set map, the tree view, select node, add TN, and I think I needed to add it, right? I needed to what? Let me check. So each time you create a fuzzy set, you need to do this thing, right? Show curve and add a series. Okay, right here. So let me go back to this button. And the last step is that my C, so I only show the final result of C show curve. I'm not going to show series or for this B. So I'm going to just show C add a series to chart. Chart, right? I don't know why we needed this card. Probably the students need it. So probably in your function, it simply is invoking your array series to chart function. Okay, so all right. So let us set a breakpoint right here to see what's going on. Okay, so if I click on this guy, if I click on the button, because this is the category, right? So I have U cast, right? S tag is none. Right now tag is none, right? Nobody there. So U is none. So it's okay. The code is saved. There is no any exception, but nothing happened, right? So I add a universe. If I click on universe, well, I think something I had better add a Gaussian function. So if a user click on Gaussian function, click this button, okay, the tag is actually a Gaussian function, right? So I'm not going to allow U not equal 0 because it try to cast as universe, right? So U is none. So it's okay, it's safe. Only user click on a universe, so that means I'm going to create a file set on this universe. So I hit this button. So right now I do have a U. Value the U. I create trapezoid for set A, right? And I'm not going to show the curve on the figure, so simply just A created. Then create B. Right now, we kind of invoke this expression. So I'm not going to step into the detail. I just hit F10 key. Oh, okay, because we set up breakpoint here, so I kind of remove that. Let it continue. So I have a C resulted right here. Probably you might wonder whether it is correct or not because we do not show A, show B, right? But it is working. It is working. So you can arbitrarily set you can use this kind of expression. That is the focus that I'm going to show you. Once you define overloaded operator, your fuzzy set operation or expression is very easy for you to do that. So later on we will use that to do something. For example, maybe another way. So maybe another case that we also have what? We also probably, and maybe we will say A intersect with B. After that, the result is intersected for this, right? Get its maximum degree. Last time we just had maximum degree, right? Use that maximum degree to cut what? To cut B. Maybe you will see it's looking like this way. C equal this way. So initially I have C assigned, right? But this, again, I changed my mind. I use that maximum degree to cut B. So finally that should be B cut, some value of the B cut, right? So let us see what will happen to check the validity of your result. So add a universe. Click on this universe. Click on this button. Let it go through. Oh, okay. I'm sorry. Probably because I'm using the work of student. And this student, you need to have an initial file set. I don't know why. So I prepare a file set define, and then I click on this guy, click on this button. It will working. So let it go through. It's really hard to identify because we have A and then B intersected. So sorry, I cannot show you the correctness for these expressions somehow. Okay, so never mind. But just remember that I'm asking you in assignment 5, you try to overload this operator as many as possible, because you can exercise so-called operator overloaded. You can appreciate the beauty of operator can be overloaded. So definitely we can take advantage of this operator overloaded mechanism to help us to compose complicate Fuzzy operation or expression. Yeah, that is the beauty of operator overloaded. Okay. All right, that's it for assignment 4. So let us go back to our assignment 5. We will study the usage a little bit about the data review. Okay. Okay, since we need to let the user specify the rule, right? So probably rule will be dynamically added, right? So the best way is that we use data review to let the user construct the rule by clicking the fuzzy set. All right, so we need some space. So let me just squeeze this there a little bit. You need to redesign your layout. Okay, just use the tab control, use read container to do that. Right now, I'm just focused on the data review. So data review is right here. Data review. So data review, we do have a name, but since it's a complicated control, so actually you can make some preliminary design via this tag, but it's not our case. We need to dynamically add a column, remove a column, right? And once you use click on the button, a new row will be added. So that is the story we are going to have. But we need to set up two data review. One is for rule construction. The other is for condition setting, because user might want to inference one condition. So in that case, user can set its condition on the other data review. So actually, we need to have a two review. So normally, if your data review has the structure is not, in one hand, you can use this construction. For example, add a column, right? Add another column, and another column, and another column, right? You can do that in that way. But it's not our case. We need to dynamically add a column, but the procedure is the same. But you need to make it using coding. Okay, but preliminary setting is important. We are not going to let the user add a new well, not this one. We will not let the user enter the data right here to create a new row. The new row always added by a button, so we need to do some initial setting. Okay, right here. So programming, we need to interact with that. So let me change the data, the variable name, data review, DGV. We call it rules, right? And since it's not freely used by the user, so we need to do some setting. So we are not going to let that user to add a row. No, we will programmatically add a row. You see what is the difference? Initially, there is a buffer row pop out. No, that's not our case. So we are not going to let the user add a row. Delete a row. No. Yeah, programmatically, the row can be added by the program. So user will hit the button to add a row, hit the button to remove it, not directly hit the key, delete key to do that. Okay, so what happened? Because what we have just done is that we kind of add a full column, right? So where should I remove those column? Take a close look at its property. Check about the correction. You see there's correction type right here. So columns is a correction. So we kind of remove it. Okay, but in this time, no, we did not confirm that. Okay, so probably we need to delete again. But here, check the column. Column do have a bunch of property can be set, right? So roughly go through the attribute, excuse me, the property of a column. So you can see this column type, data review text box, column, text box. So that is the one we like to have. You may choose different kind of column. See, button column, checkbox bar column, combo box column. Combo box column is that demo by my application. So probably later on, if you are familiar with this data review and familiar with how to set up a combo box, you can try that. But so far, we simply let our data review have this kind of column, text box column, just text. So each column will have a what? Have a header, right? So we have header text, right? Column 1. So this one we can change that, right? And another property might be related to the geometric shape, right? How about the width somehow like that? So you can set it. Okay, so we know we can instantiate the column dynamically, so no problem. So let us remove because currently there are 4. So we need to confirm it. So okay, so everything is removed. So now we have a DGB rule. Let us copy it, paste it. So this one should be for what? For condition setting. So I change the name into DGB condition. So condition will not include output universe, right? Because the user need to just specify the condition or the antecedent parts, not the conclusion part. But for the loop construction, user needs to specify the what they say on each unit, on each input units, and specify the output what they say, right? So so everything starts from here, right? From create universe. So once the user create a universe, we need to add a column right here. Okay, so let's look into the code right here. So we kind of create new universe, right? Tree node, so tree node, selection, enable, reset button. Okay, it's about the time we add. So we access that data review rules, right? Rules. Columns, there's a correction. It's a correction. Columns, you can get it. It's a property. Actually, that should be the data type is data review column correction. Add. So how can you add it? There are 2 ways. Either way, you do have a data review column ready, object ready for you. Otherwise, the second constructor, well, what it needs just a column name and the header text will be okay. Yeah, that's what we want. So column name. It has better that maybe if you make sure that universe name are all different, then we can use that. So probably I use my u.name for the column name and also the column header text. So column added. So similarly, DGV, well, we need to check it if you need to do that. Okay, so you need to do that by yourself. Okay, what I'm saying is that we just allow only in this condition. If it is the output units, we're not going to create a column there, right? So you need to check that condition. So to see whether user select this input universe or select output universe anyway. But in here, I can quickly tell you how to do that. I mean, you see, create for this, right? So for tree view, selecting the nodes, right? Add it. So we need to check the selected node. You see, right now we have a category, right? Input universe. So this is selected node. Probably the other guy is selected node. So if user select the selected node right here, is the second category, then we are not going to add output universe to the condition data review, right? Okay. So let's go back here. So normally you will have DGV condition currents add my u name, my u name, right? But it's only when the selected node, we can check what label, right? Both category are in label 0, so label does not distinguish them. The only index will change it. So if selected node index exactly equals 0, that means input category, then we add this one. Otherwise, we are not going to add output universe in our condition data grid view. So I think that's it. So let us see. So data grid view right here, right? So if a user click on this index is 0, index 1, right? Index is 0. You add the universe right here. So universe 1 is here. Universe 1, right? Yeah, it's okay. All right, so user click on this category again. We can create a universe on it, right? So universe 2, fine. And probably user click on this guy, output universe. So user add an output universe. So if a user click on this button again, your output universe, the number of output universe has more than 1. It is not allowed data. It's wrong. So you need to do some for proofs, logic checking right here. All right. So up to this point, you see, universe 3 only added to Lua data grid view. So after that, user add a file set, right? And all kind of file set on each universe, right? So you can arbitrarily set it. And output universe 2. Right, so it's about the time user want to add an if-then rule. So we should create a button here to let me add a row, and select by selecting, we will assign it into this data grid view cell. As you can see, the width by default is 100 pixel. So definitely we can set some property, right? So just keep exploring that, explore the functionality. So in here you don't have any option for setting, right? So but after that probably you can set all the well you just simply add, right? So but again you can always pick up the lately added column. How can you do that? Through this property, right? So DGB rules columns, since it's a collection, so we can use this indexer, pick up the last one, right? Last one is columns, that there is count -1. So right now we get this last column. You can access its property width, right? Width. And also we have what? We have a so-called auto size mode. We can set it. So if we set auto size mode equal what? It's a select. It's a enumeration, right? So pick up a field or cell. Now, just explore a little bit about this setting. You can choose one. So if I choose field, all right. So field. This is the only difference I made, right? So add a universe. You see field. If I add another one, field, 3, 4. So evenly share this space. This guy I did not specify that, right? So you just feel free to explore the property of this column. All right. So it's about the time we let the user add a rule, right? So this point, so button. So again, you need to take care about the enability of this button somehow. Okay. btn add a rule. So change the face text, add a rule. And for the condition inferences, there's just only one. There are just only one condition, right? So So do we need a button here, there? Probably not. But yeah, probably you need to do that. Add a rule. Okay. So similarly, we might put it here. Add a condition. Probably you don't need it. I don't know. Maybe I can just set up automatic add a row somehow. Yeah, I forget about this button. It might be confusing. Okay. All right. So add a rule, and then probably user might want to delete it. So, oops. Okay. Okay. Never mind. Here. I will let you do that. Okay, so I'm not going to show you how to do that. So later on you can find out how to do that. Change the face, delete. Selected the rule, right? So only the selected rule will be deleted. Delete the selected rule. So what else we need? Add a rule, delete rule. That's it. I think that's it, right? So inference for a condition. Okay. So subscribe the click event, double click it, add the rule. So it's very simple. Just DGV rules, right? Rows. Again, that's a correction. Add a row. That's it. Okay, so let's see. So suppose user create one, create output. It's very simple, right? And then user click on a rule, click add a rule. So add a row, add a row. If user select line hit this delete, this line will be deleted. Okay, so basically, the code behind this button click dealing with the row increasing or decreasing this manipulation, the data grid view manipulation right here. Okay, but how about the condition? We need to. Condition always just has one rule. We are not going to let the user add multiple rule, multiple condition there. Only one condition is allowed. So how can we do that? Maybe we can. Well, you cannot create a row if there is no any column. So that is the problem. So probably we will add it right here. So when we add the column, right? We add a column to this condition data grid view. We kind of check if DGV, see DGV condition, right? That guy. They have a so-called rows correction. Rows correction. Well, actually, we have a row count, so we can check row count. If the row count equals 0, right? We add it, dynamically add it. So DGV condition rows add. Yeah, we can add it without supplying any data for it. Okay, so that would be better. So universe, upper universe, user add a row. You see, that is the row we prepare. So now it's the time user construct his fuzzy rule by click the click the fuzzy set here. So suppose right now we have on universe 1 we have 2 fuzzy set, right? 2 fuzzy set, maybe another fuzzy set. So right now, similar to binary operator, we have been using these two labels to hold the operator, right? So if user click on this guy, select, we just have one fuzzy set selection, right? So if this selection is enabled, then if user click on this cell, that means user won't specify the fuzzy set on this rule, right? So, but the problem is you need to check the universe is on the same universe here, right? So how can you check that? Probably, well, maybe when we add a column, we secretly add a tag, store the universe right here. So once user click on this column, we can pick up the universe of this column and check the universe of this fuzzy set to make sure they are on the same universe. So only in that case we can accept the fuzzy set, put its name right here, right? So that's the logic. So all right, so we needed to subscribe what? Subscribe the quick event, right? So let us check the event of a data grid view. All right, so we have cell quick, right? Cell. So within this cell. So let us just subscribe this event to check the argument, what kind of information will be sent in through this event handler function. Okay, so we have a rich argument right here, right? So let us take a look at the E dot. Wow, great. We have row index. We have column index, right? So we have column index, so we can actually access the column, right? So probably we should store the column, right? But again, since it's quick, right? So we need to check whether the selected node is actually a fuzzy set. If it is fuzzy set, then we'll put this fuzzy set on this cell, right? So right now, user click a cell. So we will determine whether it is a fuzzy set. So, well, here, right? So we kind of get fuzzy set. Again, I don't care what particular fuzzy set it is. So I always use generic fuzzy set. I call it target, right? Target equal what? Equal what? Equal TRV tribute. This is the tribute, right? Tribute selected node. Tag. It always has tag. So this time we are not going to use cast, because if cast fail, then exception will be returned. And the exception, it will terminate your code execution, so it's not good. So we kind of use as what? As generic fuzzy set, right? If it is success, then target is none. If it is not success, right? So target is none. So it's pretty easy. So then if target equal none, then we simply return. Right, so let us see, check a little about this mechanism. Universe, quick, right? So we have a universe, right? So if user, well, maybe in another universe, so we have output input ready for us to use it. So it's about the time probably user add a rule. And right now, if I click on this guy, I click on this cell. So check this event, right? Says cell has been clicked. How about the E? Check it about the E. The column index zeros column, row zeros row. So fine. And how about the tag? You see the tag current is none, right? So none as generic fuzzy set. The result is okay. There is no exception came out, but it is not castable, right? So the target will be none. So in this case, now return. We are not going to set it. So okay, it's safe. It's safe. All right. Otherwise, so we need to have. Let me show you. Currently, if you click on fuzzy set, right, even though it is selected, but once your cursor move to another control, for example, right here. Excuse me. The highlight disappear, right? So actually, I think you can. In this moment, you can set this property. I don't know which one. Definitely, it is a property. It's related to selection, right? Selected selection. Scrollable select image key show. Select image index show root. Interesting. High. Do I have a high? Oh, okay. High selection true, right? Okay. So disable it. High selection false. So what's the difference? So user click on the universe, right? So universe click on it. So probably I kind of focus right here. So you can see it is graded. So the selected node is still graded. If I add a fuzzy set, right? So if I click on this fuzzy set, and I come here, the focus come here, this Gaussian fuzzy set is still selected, even though the gray is not so so obviously, but we know currently the selection is Gaussian, right? Okay. All right. So let us go back to our cell click logic main form right here, right? So it's a noun. So right now target do have, right? So we need to check current universe and fuzzy set universe. Are they the same? But we do not keep that, right? So probably we need to go back to our at the universe right here. So we create a column, right? So we know this column right here. So let me check whether this column do have a tag. Dot tag. Yes, we have. Okay. So we secretly hide the copy of our universe reference here. So we can assign my U, put it there. So the code here is that I add a new column, right? So I pick up the new column should be the last column, set the auto size to fill, and then set tag. This is my U. So later on, we can check that. Okay. So back to the this click event, cell click event. Yeah. Okay. So we will check if column. Where is column? Columns you need to access from this data grid view. So we access that from DGV rules. Its data grid view has this columns property, and we kind of use the so-called indexer to access e.column index. Right. So we get this column. And take its tag. Is the tag equal target the universe? If not, I'm not going to let you do that. And probably I don't know, maybe it will work or not. I cannot make sure. Console beep. Maybe three sound beep beep beep. Okay, just a warning message saying that well, the action is not going to work. Okay, and return. Otherwise, then we can put the fuzzy set here within the cell. So how can we do that? DGV rules rows e.rows count rows index dot cells e.column index. So we hit the cell and then we assign value. You see, value is an object, so value. So simply put our target there. All right, so let's see what happened. So we add a universe, right? And universe add the fuzzy set. We add the upper universe. Upper universe has another fuzzy set. So it's about the time we set up the rule. So we select this guy, click on this guy. Target, okay. Target is non-noun. How about the tag? Universe 1, universe 1. How about the target, the universe? Universe 1. Okay, bingo. 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 And then we put target into the sales value. Okay, it's done. Alright. So Gaussian fuzzy set Gaussian 1. Okay, that is the your toString. I think that should be your toString. So just pop up the name Gaussian 47, Gaussian 1. Okay, and then if I select this guy, click on this cell, the universe is not correct, right? Okay, so take universe 2, universe, the target, universe 1, so they are not the same. Okay, the user knowing that, well, it's not going to happen because, well, you need to have this kind of, such kind of foolproof mechanism to guarantee the user construct the right rule. So only in this case, I select this guy, click on here. So I'm not going to have already this, well, so it's okay right here. So similar work should be done in here, right? Condition. So make sure for that. Okay, I think it's probably all I needed to instruct you how to use the data group. But later on, probably the user right here, maybe select condition. Oh, I did not subscribe. I did not do that, right? So later on, user might want to inference, right? Inference the result. Put a button right here. So how can we achieve that? So well, I think I still need to do that, right? I prefer you do that. So I'm not going to implement this this functionality right here. But what I'm just want to show you that inference. So we have button. btn inference inference the given condition. Okay, so that is the method we have been using. So face text is here. So by default we kind of use cut method to generate the output file set. So once user clicked on this inference, we need to compose. We need to compose the fuzzy if-then rule. We just finished if-then rule, right? So we have if-then rule. We have if-then rule class defined. In order to create if-then rule, we need to supply an antecedent parts, right? So we also have a conclusion parts needed to be specified by the user. So either way, you prepare constructor. Right now we kind of constructor. So user will prepare this antecedent ready before he create an object or if-then rule. So we will specify our CTOR. CTOR is the secret word. Once IntelliSense highlight this secret word, you can hit tab key twice. So that user prepare this skeleton for you. So this is constructor. The constructor is a function, special function. The function name is exactly the same as the class. There should be no any return type specified. So right now we ask user, okay, user you need to prepare a list of antecedent paths. Actually, that's a list of generic fuzzy set. Get it to me. And then you also need to prepare a Gaussian fuzzy set conclusion fuzzy set. Give it to me. So you kind of restrict the construction of if-then rule. User need to prepare that in a list and then prepare the up fuzzy set. Only in this case, I can create a rule. So name is exactly the same, right? This is the local. This is the local variable. The name is exactly the same as our member. So this time we need to use the keyword this. This dot antecedent equal assign with antecedent. So this antecedent meaning what? Meaning this is the local variable. Pass in from the caller. Right? So this antecedent this conclusion to be equal conclusion for the set. Alright, so user need to prepare that. So after that, I will inference, and I return a fuzzy set, a generic fuzzy set back to you. So you need to think about how to implement that. So basically, right here, you might involve a what? Intersection might involve a cut. Somehow, look into the slide. You should implement that by yourself. So up to this point, you can create if-then rule and apply this fuzzy inference, and then you get the final fuzzy set, and then display that on the upper universe. Okay, that is the goal for assignment 5. So let me just show you a little bit how to construct the if-then rule. So right now, if-then rule, you need to prepare a list, right? You need to prepare a conclusion. Oh, okay, fine. So usually when user try the inferences, we will create that because user keep changing its rule, right? So and not just one rule, right? Probably multiple rules. Okay, fine. So within these inferences, the logic might be, well, we create rules object from data grid view rules. So probably more than one rules, right? Yes. So in that case, you will check about you needed to check probably user set up 2 rules, right? 2 rules, more than one rule. So you need to check the rows count. So each rows count, you will have that. Maybe I should not experience so many. Okay, so create rules. So how can you create that? So let me show you. If I just have one rule, you need to do that. You need to look through all these rules. Okay, so prepare if then rule, right? A rule. So you like to instantiate, right? So but we need to have a list. We need to have a generic fuzzy set. So okay. So here we have a list. Generic fuzzy set. We call it antecedent. New. It's an object. The list is we call it a temporary list. It's a dynamic framework class, so you need to new it before using it. So then we loop through what? We loop through for int equals 0, I smaller than what? DGV condition, DGV rule, colon count -1, right? Because the last column should be the conclusion, right? And I plus 1. So we kind of look through, oh, excuse me, colon count -1. So antecedent add fuzzy set. Where is the fuzzy set? DGV rules. The rows. So I'm not going to show you how to do that because you have more than one rule. What I'm showing you here, just first rule. Okay, so you need to look through all the rules and then inference each rule's result, and then union all the resulting fuzzy set to compose the final inference result. Okay, so you need to take a look at the slide and do the right calculation. Okay, so right now I'm showing you just how to set up a rule only. So rule 0 dot cell, the I cell dot value, right? So it's a tag. The value is an object, right? So we need to catch that as generic fuzzy set. So we keep correcting antecedent parts. And how about the conclusion? So we needed to prepare generic fuzzy set GONCLU-SION-FS. Well, actually, we can directly get it. How can you get it? DGV rows 0 dot cells DGV rules colon count. minus 1, this column, this cell, right? Dot value as generic fuzzy set. So just don't type the code that I show you right here. You need to, well, because probably user did not specify any rows, right? So your code will be crash, will crash. So right now I have antecedents list ready. I have the conclusion ready. So it's about the time I create this if then fuzzy rule. So I just put the antecedent part view and a conclusion fuzzy set there. So I have a rule constructed. Again, I remind you that you might have more than one rule. You need to look through all the rules one by one, get a inference result, and then union all the resulting fuzzy set to get the final result. All right, that's the responsibility. Take a look at the slide to perform the right calculation. But here I'm just showing you how to do that. I mean, you kind of create a rule, right? So you need to set up the antecedent parts and conclusion parts, and after that you need what? You need to collect condition, right? You need to collect condition. So condition similarly. So so condition just have a list of so I can call it conditions. Again, it's a list of generic algorithms. So similarly, we need to prepare that, right? Conditions at not DGV rule, DGV condition rows your cell but since all the columns are antecedent referring to the antecedent parts, so we look through I up to it's an L column count. I'm sorry about that. Column count. Sorry about that. So I now row count, column count. -1, column count, -1, yeah. Okay, column. So DGB rows 0, cell I, question for this condition. So once your rule is ready and your condition is ready, we can ask this rule, a rule inferencing. See, this if-then rule we designed it, right? We have antecedent parts, conclusion parts. So during the constructor, we ask for the necessary data. So right now, a rule is complete. Then we can inference the result for a given condition. So user need to supply this condition for us, and then we will do what? We will use the pair or condition and antecedent part do the intersection, right? And also we need to have a maximum degree, maximum degree. Yeah, use that to file. Anyway, eventually you will get a anyway, check the computation detail in the slide. You know how to do that. And right now, since we have already the operator, you can use this operator and use this property to complete your inferences. So anyway, the result will be a generic fuzzy set. But we know, since right now we use cut, so actually that should be a cutted fuzzy set on the output fuzzy set, right? So we know that, but you need to do that by yourself. Okay, so back to here. So we will invoke these inferences. So a rule inferences, fuzzy in, fuzzy out inferences. So the input is our conditions, showing DITI conditions, right? So once you invoke this rule to inference this condition, what do you get? Again, is a fuzzy set, generic fuzzy set. Again, I call it result. All right, so what I'm going to show you is that I just pick up the first rule and do the inferences with this condition. That's it. So what I get is just result of one rule. If you have multiple rules, you get this result. You need to in union with the second rule, union with the output of the third rule together in order to get a complete output. All right. So our result is not just simple with this rule. You need to union with other the result or other inference from other rule together. So that's the final result. So once you get a final result, you will display that on the output universe. So how can you do that? Well, your output universe. How can you know your output universe? It's a good question. So, well, never mind, because output file says should be defined on the output universe. So this you don't need to do that. What you need to is that result show MF curve equal true. So we need to show it up, and the result, I think, is add a series to chart, right? So my chart is GHT for the model, and I don't know why this guy need a count. Well, these students have its own count anyway. I might have count, right? I don't know why. You probably, your function is different. You don't need to follow this kind of mechanism. So basically, that is what you need to finish in assignment 5. So up to assignment 5, you let the user specify the rule by clicking the file set on the cell, and then let the user add a rule, add a second rule, and let the user specify the condition. So usually the condition also specify in here. So normally, this is the way. Well, this is the way user create input, create another input, user define output universe, right? So up to this point here, so probably user have defined several fuzzy set on each universe, right? So this is a normal situation, right? So user can change the parameter, set name, and finally user have probably, usually if we have two rules, so probably and likely we will have two output fuzzy set, output fuzzy specified right here. So keep adding a lot of things right here, right? But we cannot resize it. So it is better that we have a split container, so we can share this, we can share the space. Not that this kind of situation happen, because if your model is complicated, you kind of restrict the size of this tree view. It's not okay. All right, so user add a rule, add a second rule, right? So it's a normal case. So user click Gaussian one here, quiz triangular here, Gaussian here, sinusoidal here. Output for this, we have two rule, first rule, second rule, right? Okay, but take a close look at this message. What happened? You see, Gaussian do have a Gaussian fuzzy set colon Gaussian 1, but the rest of them, we have this namespace, right, specified, and then we have Bell fuzzy set specified. The reason is because like the units we do have overwritten the toString function, right? So it's about the time you overwrite toString function in order to make, because right now this cell we store the object, right? So by default, object needed to display its content. It will invoke its toString function. If you do not provide your toString function, the Visual Studio will use the name, the type of name. So your type is this namespace dot. Simply just show the class, the data type of you. So probably we should do that in our generic fuzzy set. So let us go back to our generic fuzzy set. So in our generic fuzzy set, we override it. Never mind, because Gaussian function can override it. So there's should be no problem. So okay, not here because it is static part. So let me move to these parts. So we are about to add an overloaded function to a generic file set. So type override keyword, the visual get it. So right now we have 3 functions not overloaded. All right, so we try to overwrite toString. So we simply return our name. That's it. So make it clear. That's it. So parent to override the toString. For the rest of file set, we do not override it, so we will use the inherit parent's toString. But only Gaussian, right? As we can remember, Gaussian file set do override it. So do override. So we have Gaussian fs colon there. So let us see what were shown up in here. So we have input universe, we have up second input universe, first input Gaussian, right? Triangular, bell, second universe, triangular, S shape, trapezoidal, upper universe, Gaussian, bell. Alright, so user create rule, click on Gaussian one, click on this guy, Gaussian one, it's okay. If still choose the Gaussian one, click on this guy, beep beep beep, not allowed, click on this guy, okay. So it will pop up, I mean it will signal the user that is illegal, right? So it's okay. So how about this triangular 2 right here? See, triangular 2 name. But for Gaussian, because we override again the toString, all right, so it has its own toString display. Let's shape it, put it here. Triangular, put it here. Conclusion part, put it here. Put it here, there, here. Okay, so right now user has constructed its rule. So it's about the time for the user to specify the condition, right? So again, condition right now is bell. So click on this guy. So you need to do that by yourself. The third one should be condition, put it here. All right, so once the user specify a rule, specify condition, then user click on this inference. Click on this inference, right? Okay, yeah, definitely it's fair, right? But normally, once you complete all this implementation, you should expect that a result will show up on the chart, right? Because the resulting file set has been defined on output universe, so you will see the result come out from there. All right, that's it. I think a lot of work needed to be done. The first thing you should redesign your layout, because we keep using a lot of control here. So you need to do that by yourself. So spend a little more time on redesign the layout your user interface. You can have your own layout. You don't need to follow the layout I made in the demo file, but roughly we need to use this control to let the user construct the rule easily, and later on we will instantiate a rule object, ask the rule object to inference its result. So it means you need to collect all the rule result together, union each output, and then show the final output on the figure. All right, that's the goal for assignment 5. Okay, that's it.